What's up everybody, welcome to my new video. Today we have a new project, keyboard instrument. This is the basis of it. It's a little diagram, it has a name, I think it's a schematic. I don't remember the exact name. Essentially what you have right here is a push button, like it says right there. Then you have a few, I'm trying to remember if I have these resistors. I might actually be able to make this one. I don't know about the piezo though, because we tried using the piezo and I don't know, I didn't do it too successfully. Or successfully at all, to be honest. But I know here that we're going to be able to do it because we have all the virtual pieces. So, reading all this right here. Just a few resistors, buttons you're going to build, boom boom, musical keyboard, so you're going to press some buttons and whatnot. It's supposed to be like, it's supposed to sound on the buzzer, obviously. The different resistor levels. I'm assuming the more resistance there is, I don't know how it works. The more resistance there is, the lower the sound or the tone of the buzzer. Or is it the other way around? We're going to be using tone, yeah, just like the last project, and that's pretty much it. The last project was supposed to be a photoresistor. The more light, it changed the tone of the buzzer. So that's what I was doing unsuccessfully. I don't know if it's the resistor that doesn't work. It's still here. It's still right here. Yeah, I don't know if I blew out the buzzer, I don't know what happened, but it sounds a lot different from when I first connected it. What I think happened was, we're coding this, right? We have raw code here. And so, I believe I left it on max for too long, so there's no stoppage, you know? Like if you have just a regular speaker, there's obviously embedded code that may keep it from, giving it max volume, as right here, there's a max. Over here with the speaker, there's no max, so maybe I went a little bit over the max for too long, and it most likely probably blew out, whatever. I don't know how much they are, so I'm still waiting on some photoresistors that I ordered. It's been like a week or two. Anyways. Yeah, so that's pretty much it for this step. Let's go on to the next step. This is what we're going to use. Let's go over to the items. I'm going to bring this to the left side here. We're going to be using a buzzer, obviously. Where's the buzzer at? Piezo buzzer. There's a few different types. There's a regular buzzer. There is I forgot what the other ones were. There's 4 piezo. There's an active buzzer and a passive, I think it was. 4 push buttons, 2 10Ks. And I have these right here. Actually, I'll just copy it here. Resistance 10K. I know which one's a copy. Yeah, copy. Paste. 10K. 1 220. So we'll bring that right here. Give it a space. 220. I know there was I think a 220. That might be for this one? 2 10Ks. 1 220. 1 million. 1 million, okay. 1 M. Or I don't know if it means 1 million. I think it means 1 million. If you're using the Arduino kit, you will also need the paper keyboard template, which I don't have. 1 million right here, a green one. It's the first time I see that. Usually we always use 220s, and 10Ks for all the past projects. If you're using the Arduino kit, yeah, you name the template. Can you match each component on the list to its location on the breadboard? I could, but usually what happens here is that this is the old version. See how there's a different buzzer, and it looks a little bit different, the buttons even, the wires. It's an old version, and it's not even an Arduino. Probably before they got the license to use Arduino. And so it always switches up to the more modern version. So can you match it? We'll just answer the question. Yeah, it's literally just, just a picture. Continue to the next step to learn how to set up the circuit, and that's where it modifies it. So the resistor ladder. Look at the resistor ladder, which connects 4 buttons. All the buttons share one terminal connection at pin A0. Pin A0. So this is the top of the Arduino, the bottom, top right here with the digital pins. The ground over here shows the ground on the right side, but it's just a visual. The ground is right here, any of these two. If no buttons are pressed, 0 volts. Pressing the first button results in the 5V input and so forth. Pressing the third button, 2.5. All because of the resistance. Alright. So, what else we got? You will see the unique input voltage produced. We'll probably see that in the serial monitor. If you press the 2 buttons at the same time, you will get a unique input based on the relationship. Continue to the next lesson to learn how to build the circuit. Yeah, that's pretty much it. As far as this part goes, it's 4 out of 4. We're gonna go on to the next one, probably in a new video. Thank you guys for watching. Y'all have a good ass video. A good ass day. Peace out.